In this exercise, we have 6 interconnected switches. We have 3 VLANs. VLAN 10, which is orange, it's called Human Resources. VLAN 20, which is green, it's called Finance. And VLAN 30, which is blue, and it's called Legal. Our first task is to configure host names on all switches, and also while we are configuring host names, we can also configure rapid per VLAN spanning tree. And it says here on all switches underlined. I didn't mention this during the explanation video, but you do have to configure the same version of STP on all switches. It could happen that things could work properly and you wouldn't even notice the difference, but it really depends on the topology. So you should really make sure to configure the same version of STP on every switch in your network. Let's start with the first task. I'm going to go one by one. So switch 1, host name S1, spanning tree, mode rapid PVST. Now this is the shortest version of the command. SPA short for spanning tree, and then MO short for mode, and then you can just say RA short for rapid PVST. First task done. Let's move on to the second task. Configure access interfaces and VLANs, 8 interfaces per VLAN plus port fast. We already know how to do this except for port fast, but luckily the port fast command is quite simple. Here it is. You just need to type in spanning tree port fast and make sure that you are only typing that in on interfaces where you know there will be no loops. So on access interfaces to which endpoint devices such as a PC or a printer will be connected. Let's start with S1. So we're going to do interface. I'm trying to type the entire command. Interface range fast Ethernet 0/1 to 8. And that is going to be in VLAN 10. So we're going to say switch port mode access, switch port access VLAN 10. And then spanning tree port fast. We get this warning that says port fast should only be enabled on ports connected to a single host. Connecting hubs, concentrators, switches, bridges, etc. to this interface when port fast is enabled can cause temporary bridging loops. Use with caution. All right, now that we've read that, we're going to move on. Interface range Fast Ethernet 0/9 to 16 is going to be in VLAN 20. So we're going to say switch port mode access first, switch port access VLAN 20. Spanning tree port fast, and that's it. Sorry, these commands disappeared too quickly because this message is quite long. Right, so it printed a warning for each of the interfaces that were in this range. So these were the commands I used in case you missed them. That's it for switch 1. Let's move on to switch 2. Here we're going to go to interface range fast Ethernet 0/1 to 8. Switch port mode access, switch port access VLAN 30. Spanning 3 port fast. Interface range 0/9 to 16. Switch port mode access, switch port access VLAN 10. Spanning tree port fast, and I'm going to wait a little bit so that you can type that in, and then we're going to hit enter. That's it for switch 2. Switch 3. Interface range fast Ethernet 0/1 to 8. Those interfaces will belong to VLAN 30, so we're going to say switch port mode access, switch port access VLAN 30. Spanning 3 port fast. Exit interface range fast Ethernet 0/9 to 16. Switch port mode access, switch port access VLAN 10. And then spanning 3 port fast. We need to be a bit more careful with the next interface range, because in this case we are using the fast Ethernet 0/23 port for trunk. So we should make sure to not add that to access interfaces, and also to not configure port fast on those interfaces. So I'm going to use less interfaces here. So instead of 8, we will use 6. We're going to go interface range 0/17 to 22. Interface range fast Ethernet. Okay. Switch port mode access, switch port access VLAN. That's VLAN 20. Spanning tree port fast. That's it for switch 3. We can move on to switch 4 now. From 1 to 8, switch port mode access, switch port access VLAN 20. Spanning 3 port fast, and then interface range fast Ethernet 0/9 to 16. Switch port mode access, switch port access VLAN 30, and then spanning 3 port fast. And I have just now remembered this. I'm going to make this a bit bigger so that you guys can see what's going on in the command line interface. Hopefully it's better now. So we've configured everything for switch 4. Switch S5 doesn't have any access interfaces, so we're going to skip S5 and go straight to switch S6. Enable configure terminal, interface range fast Ethernet 0/1 to 8. Switch port mode access, switch port access VLAN 30. Spanning tree port fast. Second task, done. Third task says we need to configure trunk interfaces, and this should be simple since we have already done that. So all of the dashed lines, so all of those links that connect switches should be trunk links. Let's start from switch S1. I'm going to use range for the gigabit Ethernet interfaces. So I'm going to say interface range, gigabit Ethernet 0/122, switch port mode trunk. And then fast Ethernet 0/24, switch port mode trunk. I've already mentioned this once, but you don't actually need to type exit here. You can just go to another interface. So interface fast Ethernet 0/23 is what I need now. And I'm going to say switch port mode trunk. Another thing you've just witnessed, I went ahead of myself and I didn't press enter to get to this point, to get to this part. I typed in exit right here in case you missed it. So you don't really have to press enter or wait for this to show up. You can type exit right after this warning or information. This is kind of an information. Okay. Let's go to switch 4. Same thing again, okay. Exit. Now S5 is going to have 4 trunk interfaces, so I'm going to say yes, T. Gigabit Ethernet 0/122, switch port mode trunk, and then interface range, fast Ethernet 0/23 to 24, switch port mode trunk. S6 only has 2 trunk interfaces, so we're going to say interface range, gig Ethernet 0/122, switch port mode trunk. Task 4 completed. Oh, sorry, that was task 3. So trunk interfaces are configured. We should go to task 4 now, configure root switches according to the diagram. If you're wondering where this is noted on the diagram, just look at this area right here, and you will see that for each VLAN, you have information on which switch is a root bridge for that VLAN. So for VLAN 10, root bridge will be switch 1. For VLAN 20, root bridge will be switch 3. And for VLAN 30, root bridge will be switch 5. The commands for this are very straightforward. So we're just going to go to switch 1 first, and that switch should be a root bridge for VLAN 10. Let's go to switch 1. All we need to say to the switch is spanning tree, VLAN 10, root primary. But before I do that, I want to show you something. So I'm going to do show spanning tree. This command will give me all sorts of details about the spanning tree process on this switch and generally in this network. So for VLAN 10, that's what I'm interested in. It says that root ID, so the root bridge ID, the ID of the current root bridge, is 32,778. This is the priority value we talked about in the explanation video. The default priority value is 32,768, But in order to get this ID number, you add the VLAN ID to the default value. So it's 32,768 plus VLAN 10. That is how we got 32,778. The priority of this bridge or of this switch is 32,778. So the priority is the same. And by coincidence, this bridge is the root. It's probably because this was the first switch that I added into this network right here when I was creating this packet tracer file for you. And that switch got the lowest MAC address. So that's probably the reason why this switch is the root. But we definitely want to influence that. So we're going to give it this command: spanning tree, VLAN 10, not 0, 10, root primary. And then I'm going to repeat this show command, do show spanning tree, and then we will see the new priority, which is 24,586. So again, it's 24,576 plus the VLAN ID number. In short, what this command did is it reduced the priority value by 2 times 4,096. In case we wanted to have a backup root bridge, we could go to switch 2, for example, and type in spanning tree VLAN 10 root secondary. And in that case, that switch would get priority value 32,000 and blah blah minus 4,096. So we would get some value around 28,000 and something. Let's move on now. Switch 3 is going to be a root bridge for VLAN 20, so we're going to give it the same command that we did on switch S1, only we're going to use VLAN 20 in the command. So I'm going to say spanning tree, VLAN 20, root primary. Just for fun, I'm going to issue do show spanning tree here as well, and look at VLAN 10. That's what I'm interested in. So this bridge's ID, or this switch's ID priority value, is 32,768 plus VLAN 10. This is what it tells you, so you don't even have to memorize this information. And then the root ID in this network has the priority of 24,586. That is switch S1. Let's go to S5. S5 is going to be a root bridge for VLAN 30. Now we may run into trouble here, but we're not going to really test this network yet. But S5 is not aware of any of the VLANs in this network. But let's issue this command and we will worry about that later. So spanning tree VLAN 30 root primary. Next task, and the most boring task, since we don't have any routers or any DHCP servers here, we will have to configure the IP addresses on PCs manually. In next exercises, I will make sure to configure the IP addresses for you whenever they need to be configured statically, so we don't have to waste time on that. But this time, let's do it together. I'm going to start from VLAN 10 computers. We only have 3. It's A, D, and F, and they should have IP addresses 192.168.10, and then we can give them 123. I'm going to copy this part. For VLAN 20 computers, it's going to be the same, the only difference is in third octet. It's going to be 20 instead of 10. So let's start with J. And in VLAN 30, we have 4 computers. And we'll do the same thing, only the third octet is going to be 30. The next thing we need to do is save this packet tracer file now, because we will use this exact file in the next exercise. So make sure to save it. I'm going to save STP without VTP. So this is not clean anymore, so I'm going to make sure to not save the previous exercise, right? So packet tracer STP without VTP. Save. And then the next task is to add all VLANs on all switches manually. I'm going to go to switch 1. Switch 1 already knows about VLAN 10 and 20, so the only thing I need to do is say VLAN 30. Here we're missing VLAN 20. On switch 3, we've got all 3 VLANs. On switch 4, we are missing a VLAN 10. On 5, we don't have any of the VLANs, so I need to create all of them. And then on 6, we are missing VLAN 10 and VLAN 20. Now all that is left to be done is to try if the communication is working. So I'm going to try to ping in between different computers in the same VLANs. So I'm going to say simple PDU from K to C, for example. Okay, that's successful. For some reason, I can't make this go to the left. Okay, this is gonna work. And then from B to G, for example, from A to F, and we can see that all of the tested communication is working. Now what I would like to show you are some additional STP commands. Let's go to switch S1. I'm going to say show spanning tree active. This command, so this is VLAN 1, I'm not interested in that. I am interested in VLAN 10, VLAN 20, and VLAN 30. So let's take a look at VLAN 10 first. The output of this command will show you information about the current root bridge in your network. Now for this VLAN, this switch is the root switch. So these two columns are pretty much going to be the same, but it's also going to show you the status of these interfaces. Now all of the interfaces on a root bridge are going to be in forwarding mode. We have already mentioned this. And all of the interfaces are also going to be they're going to be designated ports. So this is what they are called. Let's look at VLAN 20. For VLAN 20, we have a similar situation, The only difference is that this switch is not a root switch for VLAN 20. So you will see different information for root bridge and for this bridge. So this bridge's priority is the default priority plus VLAN ID, which is 20. And root bridge's priority for that VLAN is a different one. Also, all ports for this VLAN are as well in forwarding mode, and we have one root port here. So this is the root port in perspective of switch 3, which is the root bridge for this VLAN. So for this VLAN, the root bridge is S3, and obviously Gigabit Ethernet 0/2 is going to be the cheapest port to send a packet toward switch 3. If you look at other possible routes, the packet could go through 2 fast Ethernet links, or even worse, through how many links do we have here? 4, or maybe go through this and then this one and then this one, which is 3. So this is definitely the cheapest link. That is why Gigabit Ethernet 0/2 is the root port for VLAN 20. Let's go to VLAN 30. In VLAN 30, we have one port that is blocked, which is actually okay. If you look at root bridge, so root bridge for VLAN 30 is S5, and now you may ask yourself, or me, well, how come this port is blocked when it's directly connected to the root bridge? Well, this switch is not particularly important in the VLAN 30 spanning 3, because this switch doesn't have any VLAN 30 access interfaces. So we don't have anything in VLAN 30 on this switch. Unfortunately, as you can see here, it's not that simple to reconstruct a spanning tree for multiple VLANs in a network like this. So it's not as simple as I showed it in that presentation, where I made the active interfaces in a certain color and you can clearly see what is the tree. In order to figure out what the tree looks like in a network like this, you would have to issue these commands on each switch and look at the results and look at which ports are blocked and which are forwarding, and then try and draw that tree yourself. But that is it for this exercise. See you in the next one.